So this is Marshall, and this is the second part of the trig review lesson for physics. I originally did one in class, video from the class, but I wasn't happy with that as far as the assignment goes, so I'm re-recording this, and hopefully this will allow you to do well on the worksheet. So if you want to see the class notes for this in Canvas, if you go to Course Outline and you go to Trigonometry Review Part 2, this takes you to the actual class notes. Okay, and this is what I'll use to go through the video with. You also have a review sheet. The review worksheet. Well, actually, this is the sheet that I'll use to go through the lecture with. But you have a review worksheet. Let me do that. Okay, and let's just read through this here first. So hopefully you've printed this out. So to complete this section, follow the instructions on the video. The first 4 exercises require the use of a trig table that you can find at the link shown. And I already have that pulled up here. Let's see. So this is that worksheet, or that trigonometry table. The trig table, and hopefully you remember that from the first trig review exercise or assignment. But anyway, these are the class notes, and so we won't go through all of these exercises. I'll just do some, and then you should do the rest of them. But in the class notes here, make sure you understand that if you go to this page, this class notes page for the Trigonometry Review Part 2, you can check your answers here. So if you go to that, you'll see that the answers for the first 4 exercises are right there. Okay, please do the exercises. Don't just go to the table and write down the answers. So we'll go through some of these as examples, and then I'll let you do the rest on your own. You can turn those into me. So for this first part here then, if you go to the notes, or you go to your worksheet actually, and here are the notes for that. It says, given the following values for sine, use the trig table to determine the angles between which the actual angle must be. And remember, when we talk about this, remember that if I define the sine of theta, that's going to be the opposite side of the triangle over the hypotenuse. If I have those values, I can find out what that is. But if I have the sine of theta, and you can see here my first one is 0.6092, if I have that value, I can go backwards and I can find the inverse sine. Okay, and that's what we're actually doing here. We're finding the angle from the value of the sine. Okay, and remember that when we're talking about the sine, that 0.6092 is the ratio of the length of the opposite side of the triangle. So here's theta. This is the opposite side, and this is the hypotenuse. This value, 0.6092, is the ratio of this length to the length of the hypotenuse. So all this really means, this 0.6092 means, is that this side of the triangle is 0.6092 times the length of the hypotenuse. Okay, so that's all that means. So what I want you to do here then, you've got the values for sine. So the first thing I want you to do is go to the trig table, and that value 0.6092, here's the sine column right here. Okay, this is the sine column right here. And I want you to go down to the value of 0.6092. Well, there isn't a value of 0.6092. It's between 0.6018 and 0.6157 though. And so that value of 0.6092 is going to occur somewhere between an angle of 37 and 38 degrees. Okay, so you're going to go to your worksheet, and on your worksheet you're going to say that value is between 37 and 38 degrees. Okay, and then what I want you to do is find the exact value to the nearest hundredth on the calculator. So it's going to be somewhere between that angle, and let's make sure we understand how to find it on the calculator as well. And so I've got a scientific calculator here, and hopefully this is close enough to what you would see on your calculator. Okay, that we can do that. And actually, let's not go to that calculator. Let's go to this calculator. Okay, so this is just a web-based calculator, and what you're going to do then is to get to the inverse sine. Okay, to get to the inverse sine, on your calculator you're going to hit the second button, and then you're going to hit the sine button, and it may say a sine, which means arc sine. It may say a cosine or arc cosine or whatever it is. But when you do this, when you hit that second sine button, it'll show you sine to the negative first on your calculator, and it will give you a parentheses, and you just plug the value in, 0.6092, and hit that, and it will give you the value of the angle. So the angle is 37.5 degrees. Okay, so I'm going to go back to my notes, and I wanted it to the nearest hundredth, so it said 37.53 degrees. Okay, so and let me show you how to do one for the opposite side of the trig table, because the trig table is a little funky here. Let me go back to, let's look at 0.8888. Okay, 0.8888, and we'll go back to the trig table, and for angles that are higher than 45 degrees I have to use the other side of the trig table. Okay, and notice that down here at the bottom I've got to use the column that says sine for the opposite side of the table here. So the bottom row here, this bottom row tells me where the sine column is. So the sine column is now here for the angles greater than 45 degrees. So if I go to the sine column for that, and I go up to 0.8888, again, I don't have that exact number, but I have 0.8829 and 0.8910, and then I go over here and look at that angle, and that angle is between 62 and 63 degrees. Okay, so at an angle of 62 to 63 degrees I get a sine of 0.888, and so I'll go back to my worksheet and say that that angle is between 62 and 63. And then I'll go to my calculator, clear the last one, and again I'll say second, and I want the sine of that, so the arc sine or the sine to the -1, it's the same thing, and I'm going to plug in 0.8888, and that's going to give me 62.7 degrees. So again, we can 772. Okay. So again, we confirm that this is somewhere between 62 and 63 degrees. 62 point, and I forgot what it was already. 6.72 degrees. Okay. So that's what I want you to do with the sines. Okay. Now let's look at the cosines. Again, we'll use that same table. So now I've got 0.6092, and I'm going to look at my trig table for cosine. Oops, let's go to the trig table. So that will get you through these exercises. Oh, and by the way, there's one thing that I'd like you to think about as you're doing these. As you're looking at this, I want you to actually think about what the sine means and understand that it means the length of the opposite side is 0.6092 times the length of the hypotenuse. What does that mean for the size of the angle? And what I mean by that is this. I want you to realize that if the length of the opposite side is about 0.6 times the length of this, then that angle should be somewhere around 30 or 40 degrees. And we said it was, I forgot what we said it was already. But if I've got a sine where the opposite side is most of the hypotenuse, so here's the opposite side, and here's the hypotenuse, and this opposite side is most of that length of that hypotenuse, I'm going to have a much greater angle, and we said that that angle was 60 some degrees, right? So think about that idea that the length of the opposite side compared to the hypotenuse will determine how great that angle is. So the longer the hypotenuse or the opposite side compared to the hypotenuse, the greater the angle will be. And so I just wanted you to think about that. Okay, and here's the cosine one. Okay, so if we go to our trig table and we look at the cosine, and here's the cosine column, 0.6092, 0.6092, 0.6092, and I realize, well, I get down to an angle of 45 degrees, and I haven't gotten to 0.6092 yet. I'm going to have to find that for the opposite side here, for the larger angles. And so if I go and see where the cosine is on my bottom row here, so cosine is this angle. If I go back to 0.6092, I remember that it's actually here where I had 0.6092 for the sine, but since I'm on the opposite side here, 0.6092 is now going to apply to 52 to 53 degrees. Okay, so my angle is going to be between 52 and 53 degrees for that. Okay, so 52 and 53 degrees. Oops, and let's do that on the worksheet. So between 52 and 53 degrees. So if I go to my calculator and plug 0.6092 in for the cosine, so here's my calculator. I hit second, and then I hit cosine, and that's going to be cosine to the negative first then. And I'm going to plug in 0.6092, and just like magic, I get that is 52.47 degrees. So I come over here and say 52.47. So if my cosine is 0.6092, then my angle has to be 52.47 degrees. And let's do the 0.888 one again for this. If I go to my trig table again, oops, it's my trig table, and I look at cosine, and I go down here and I find 0.8888. Oh, it's that same one that I had before, but recognize if 0.888 is between these two numbers, now since I am going from this side, it needs to be this angle that I talk about, 27 and 28 degrees. Okay, so 27 and 28 degrees is the angle that I need to put here. Okay, and if I go to my calculator and I say second cosine and put 0.8888 in there, this time I get 27.28 degrees. And I'm just rounding it, right? So 27.28. Degrees. Okay, so that's how I do those. And you can do the rest. And again, if you want to check your answers, go to Canvas for this lesson. And again, if I click here, I get the answers for this set. If I go to click here, I get the answers for the cosine set. Okay, and then I want to notice something very interesting here. So on your worksheet, it also says, think about this. Here's something interesting, and you may already have noticed it. If you add up the values of the exact angles for each value of sine and cosine as follows. So if I look at the value of the angle for the sine, where the sine is 0.6092, and the angle where the cosine is 0.6092, if I add those up, 37.53 plus 52.47, I get 90 degrees. And notice that if I do the same thing for the sine of 0.888 and the cosine of 0.88, I have 62.72 for the sine. Oops, 62.72 plus, and for the cosine, 27.28. Again, those add up to 90 degrees. So what I find out then is if I take the sine, the angle for the sine and the cosine of the same value, so 0.0035 sine, the inverse sine of that, and then the inverse sine of the cosine for that value, I should get complementary angles. I should get angles that add up to 90 degrees. And I want you to confirm that for the rest of these three, this one, and this one. Show me what the angles are for the sine and the cosine of 0.0035 and 0.1987, and add those up together and show me that they equal 90 degrees. Okay? So that's the third part of this first part of this exercise. Okay? And that's because these are reciprocal functions. And what that means is that if you multiply the functions together, they'll multiply out to 1. Okay? So These are reciprocal functions. And I want you to show me that you got that. Okay, so again, if I find the angle for the sine and cosine of the same value, those angles should add up to 90. They'll be complementary. Okay, and then we want to do the same thing for tangent, and I'll do the first one here for you. Well, actually, I'll do a couple of them so that we can get both sides of the trig table thing. So if I have a tangent of 0.0178, and I go to my trig table, and I see tangent here, 0.0178 is going to be between this number and this number. So my angle will be between 1 and 2 degrees. So I'll go to my worksheet and I'll write down angle is between 1 and 2 degrees. And now I want you to find the exact value of that, just like we did with the sine and the cosine. And so I'll go to my web calculator here. Obviously, you can just use your own calculator. And just as I did before, I'm going to hit second, and then I'm going to hit tangent, and that's going to give me the inverse tangent here, this tangent to the -1, which is also called the arctangent. And then I'm going to plug in my value, 0.0178, and hopefully this will give me a value between 1 and 2. And it does. It gives me 1.0, and we'll round it up to 1.02. So I'll go to my value there and say 1.02 degrees. Okay, let's look at this 30.905 for the tangent. Okay, and that's going to be on the other side of the table, so we'll go to the table. And I forgot what it was already, 30.905. Okay, so 30.905. And so I scroll down with the tangent here, scroll down, and I notice that I don't get to 30.905 yet. So I'm going to have to go to where the bottom says tangent, and then I'm going to have to scroll back up to where I find 30.905. Okay, and I notice that's going to be between 28.6363 and 57.290. So that angle has to be between 88 and 89 degrees. Okay, 88 and 89 degrees, and so I'm going to go back to my worksheet here and say that's between 88 and 89 degrees. And then I'm going to find the exact value with the calculator. So I'm going to go back to the calculator, and I'm going to clear the previous one, and then I'm going to say second tangent and remind myself what the angle was, or what the value was, 30.905. And I'm going to plug that in. 30.905. Close my parentheses. And that's going to equal 88.15. Okay. So I'm going to say 88.15 degrees. Okay, so now you should be able to complete those as well. So these four, they should go pretty quickly. They're a little tedious, but use the trig table to find out what the angle would be for these values of sine, and then your calculator to find out what the angle would be for the calculated values, and then for the cosine as well, and then show me that the angles for the sine and the cosine add up to 90 degrees, and then do the same thing for the tangent. Okay, so that's the instructions for that. And again, if you go to the class notes for this in Canvas, okay, that's this page right here, right? And I get to that by going to the course outline and clicking on Trigonometry Review Part 2, and I can find the answers for that, for the sines, for the cosines here, for the angles adding up to 90 degrees. I can click there and find that set of answers. And then for the tangents, I can click that set of answers. Okay, so now that we have hopefully a good basic understanding of how this is going to work with the sines, cosines, and tangents, how do we use these in physics? Okay, so far it's just been kind of busy work learning the basics of this. We need to figure out how this is going to work in physics. Okay, so let me go back to the one that I can write on. I can't write on this in the browser. So here, how to use sine, cosine, and tangent to find unknown sides of angles of right triangles. And that's what's going to be important in physics. So in the introductory problem, we saw that in solving some types of physics problems, we might have a critical need to be able to determine the value of unknown lengths of sides and angles. Okay, so remember we had an airplane that was traveling at 100 meters per second to the east, and we had a wind that was blowing, and I forget what the actual value was, but let's say 20 meters per second to the north, and we wanted to find out what the actual value of the velocity was going to be and what the angle was. Okay, so we might have a need to identify the value of unknown lengths of sides of a right triangle. That's what our need is. Underlying this skill is the understanding that for a specific angle in a right triangle, the ratio of the length of any of the sides to one of the sides is a constant value, no matter what the actual lengths are. So in this circumstance, if I keep a ratio of 1 to 5 here, 20 to 100 is the same as 1 to 5, then if I had like a triangle where it was 100 to 500, that angle would still be the same, and that's all that we're saying. So for a particular angle, we can either look up these ratios or we can find them using a calculator. And then knowing these ratios for a particular angle, if you know, and here are my two basic uses. If I know the length of one of the sides and the angle, I can find the length of the other side. If I know the lengths of two sides, I can find the length, or I can find the degrees of the angle. Okay, and so this last set of exercises here is going to guide us through and give us practice in the strategy we need to follow to develop these necessary skills. Okay, so just to remind ourselves, okay, what our skills are. Okay, so if I have a triangle, a right triangle, and I know that it's a right triangle because I've got a right angle down here, right? The first thing I need to know how to be able to do with 100% certainty is label the sides of the triangle with hypotenuse, adjacent, or opposite. Okay, and so my angle that I want to do this for is right here. Recognize if I chose this angle, my sides would be different. Okay, but we're choosing this angle right here, this theta, and I want you to label the sides of this triangle, H for hypotenuse and A for adjacent, and O for opposite. And we know that this is the hypotenuse, and we said there were two ways that we could remember why this is the hypotenuse. One, it's the longest side of the right triangle. Okay, the hypotenuse will always be the longest side, and I can see that this is the longest side here, right? I can see that's the longest side. It's longer than this side, and it's longer than that side. Or I could say, I know that the hypotenuse is the angle that's on the side of the triangle that's opposite the right angle. So if I look across the triangle, from the right angle, the hypotenuse is going to be that side. Okay? The adjacent side is the side of the angle, or the side of the triangle that's next to the angle that I want. I want this angle right here, theta. I want to know about that. So this is the adjacent side. That means next to. Adjacent means next to. But you could say, Marshall, well, the hypotenuse here is also adjacent to this angle. It's next to it. And I would say, yeah, but we've already given that the name of hypotenuse, so I can't call it adjacent anymore. I can only call the one that's not the hypotenuse, the adjacent side. And then if I look across the triangle, to that side's going to be the opposite side. So all I need for you to show me is that you've correctly labeled this triangle for that particular part of the exercise. So here on your worksheet, you would just say hypotenuse, adjacent, and opposite side. Okay? So we have defined the sine of theta as the ratio of the opposite side to the length of the hypotenuse, right? I've got the length of the opposite side to the length of the hypotenuse. So the sine of theta is defined as the ratio of the length of the opposite side to the length of the hypotenuse. Okay? And hopefully you remember in our class notes that if I go to my class notes, one thing I can do here is I can show you what the correct labeling is, right? Okay, so I've got that diagram there showing it to you. If I click on that, and then when I have blanks that are blue lines in the class notes, if you hover over them, they'll show you the answer to that. So opposite and hypotenuse. Okay, and so on your worksheet, you would come in here and say opposite and hypotenuse. Oops, except I've got to spell it right, don't I? Hypotenuse. Okay, and then for the cosine, you know that that's going to be the ratio of the length of the adjacent side to the length of the hypotenuse. And then for the tangent, you know that that's going to be the ratio of the length of the opposite side to the adjacent side. Okay, we don't want to write these words out all the time, so we're just going to abbreviate them H, A, and O. And so I know that with these abbreviations, and again, this is going to go in your worksheet, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And I want you to remember that we've created a mnemonic that's going to help us out for that, right? We've got the mnemonic SOHCAHTOA. SOHCAHTOA. And so I know that S stands for sine, and that's opposite over hypotenuse. right? Sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, SOHCAHTOA. That mnemonic will help you remember all of these things. Okay, so for the next part of this then, I've said in your worksheet to complete the section, follow the instructions in the video and the instructions below. And I've given you 3 right triangles. There's the first one, there's a second one, and there's the third one. Okay, so I've given you 3 right triangles, and it looks like a lot of empty space there. Okay, so this is your, again, this is your worksheet that I'm looking at. And for each right triangle, I've given you all 3 sides of the triangle. So if I go look at this first triangle, I can see that I've given you the hypotenuse, and I've labeled it V equals 14.7. I've given you the opposite side, at least if we're referring to theta 1. I've given you the opposite side, that's 3.31 meters per second for that velocity, and then VB equals 14.3 meters per second. So I've given you all 3 sides, okay? And then get used to the idea that we'll commonly label sides of the triangles with variables that mean something to us and their corresponding value. So again, I've said V and VA and VB, and what we're saying here is that this is a velocity. So this vector represents velocity A, my first velocity, and I'm adding this velocity here to vector B, which is 14.3 meters per second, and I'm getting this total velocity. So the addition of this velocity plus this velocity gives me the velocity represented by this arrow, this vector here. And if I do the Pythagorean Theorem, I can find out that the overall velocity, if I add these 2 velocities together, just like with my airplane problem, gives me 14.7 meters per second. Okay, so and I'm not trying to get you to do that part of the problem right now. I'm just trying to show what applies to sine, cosine, and tangent here. So in all of our situations, we'll label the sides of the triangles with variables that mean something to us and their corresponding value. So I've labeled V, VA, and VB. That refers to velocity, velocity A, and velocity B. So it won't only be important for you to recognize the hypotenuse, adjacent, and opposite sides, but that these sides correspond to something in a physics problem that you can substitute in for the values of hypotenuse, opposite, and adjacent sides. And that's going to help us solve these problems. So recognizing this will allow you to figure out which trig function you need to use to solve the problem. So for each triangle, I've listed 2 angles. The 2 non-right angles, I've said one of them's theta 1 and one of them's theta 2. And so what I want you to do for each of these is write out the general formula for the trig function asked for using the standard abbreviations. Then write that formula in terms of the labels on the triangle, and then plug the values in and solve. Okay? Now, recognize that the adjacent and opposite side will be different depending on the angle. So if I have theta 1 here, right, here's theta 1. If I have theta 1, this side will be the opposite side, and this side will be the adjacent side, and this side will be the hypotenuse. If I have angle theta 2, the hypotenuse will still be the same because that's always the side opposite the right triangle. But for theta 2, this will be the opposite side, and this will be the adjacent side, or this will be the adjacent side, and this will be the opposite side. And that's backwards from the way it was for angle theta 1. Okay. Also recognize that one of the functions for each angle has been done for you. In fact, we will do all three of these for angle 1. I've only shown you sine, but we'll do cosine and tangent as well for each of these, and we'll also do that for angle 2. Okay. Remember also that as the ratios of the lengths of the right triangle, the final values won't have any units. They're just ratios. So I've completed the sine of angle theta 1, and that's simply a ratio telling us that side VA is about 1/4 as long as side V. And you can look at that and you can see, yeah, I can see that. I can see that the hypotenuse is probably about 4 times as long as side A, or as the adjacent side. Okay, or as the opposite side, I'm sorry. Okay, and then finally recognize that there will only be one angle that can give us that one angle. It doesn't matter what that angle is right here, but only that particular angle can give us this ratio of the opposite side to the hypotenuse. No other angle can do that. Okay, and we're going to round all values to thousandths places. Okay, so for triangle 1, I've already done this first one here for you, and here's theta 1, and I know that the sine of theta of any angle is going to be the opposite over the adjacent. And let me get to a thing that I can write on here. Okay, so here's my oh, actually, let's do it on the, and I'll just kind of skip back and forth here. So here's my actual worksheet. And so I've said sine of theta equals opposite over hypotenuse. For theta 1, this is opposite, and this is hypotenuse, right? So that's the opposite side. And so I've also said, well, guess what? The opposite side is also VA, and the hypotenuse is also V, so I can substitute those in. And then that makes it really easy for me to see, oh yeah, that sine is 3.31 over 14.7, and that gives me 0.225. Okay, so let's do the same thing for the other two here. Okay, so cosine is adjacent side over hypotenuse, and in this case the adjacent side has been labeled VB, and the hypotenuse is V. Okay, so all I need to do to find that value is plug those values in, 14.3 and 14.7. And again, I don't need to put units because this is just a ratio here. And let's go to here to find out what that value is. That value is 0.973. And you can see that this is almost as long as the hypotenuse, right? This angle is so small, it's so shallow, that the adjacent side is almost as long as the hypotenuse. So that ratio is almost 1. I can do the same thing for the tangent. I know that the tangent is the opposite over the adjacent, right? SOHCA TOA. And so that means that VA over VB equals 3.31 divided by 14.3. Okay, and if I go look at the value that I've already calculated for that, it's 0.231. So 0.231. Okay, so that's what the values are for angle theta 1. Okay, now because I'm changing the angle, I'm I'm going to erase my labels for opposite and adjacent. And now I'm going to say for angle theta 2, this is the adjacent side, and this is the opposite side. And if I label this, and I'm really consistent and faithful about this, every time I do this, it gets easier for me to see what these things are without the labels. Okay, I can just almost do it in my sleep at some point. Okay, and so now I want to find out what the sine of theta 2 is, and I know that's going to be the opposite over the hypotenuse. So I write that in, and then, oh yeah, the opposite side is VB, right here, and then the hypotenuse is V. So VB over V, and then I substitute the value in 14.3, 14.7. Okay, and interestingly, this is the same value that I had for the cosine on the complementary angle. That's why they're called reciprocal functions, because the sine and cosine of one of the angles is going to be the complement or the reciprocal of the values for the complementary angle. So for theta 2, we can go ahead and say this is A and this is H. And again, A is VA, so I'm going to substitute that label in there. And my hypotenuse was V. And my value was 3.31. And my value for this was 14.7. And it's going to make sense then that this is the same as my value for the sine up above, because now I know that those are reciprocal functions. That's going to be 0.225. Okay, and then for the tangent, opposite over adjacent, I go back up here. Here's my opposite side, that's VB, right? That's VB, and my adjacent is VA. So now it's going to be VB over VA, and VB was 3.3, or VB was 14.3, and VA was 3.31. And if I do that, I find out that that value is 4.32. Okay, so hopefully this makes sense, and I'm going to ask you to do the same thing for angles 2, or for triangle 2 and triangle 3 on your own. Okay, and remember that you can always go to Canvas, to the class notes for this, and I've told you that you can click to find the correct value. So only use this to check your answers, okay? Don't just go and copy the answers. That doesn't help you do anything. And then for triangle 3, it's the same there, okay? So that's question 7. Okay, so these last two exercises, 8 and 9, are going to show you where the real power of this stuff comes in for physics, okay? This is where we're really going to find out how this is useful for us. Okay, Okay, so this is back into your class notes here. So this is what you'll see in your class notes. This is the one that I can write on. The basic strategy for this, and again, we're going to say if we're given one angle, if we're given an angle and one side of the right triangle, we can always find the lengths of the other two sides. And the basic strategy is this, okay? So this, you know how big I am on strategies. So here's my strategy for this. Okay, if I have a side and an angle and I want to find another side, the first thing I'm always going to do is I'm going to write down my hypotenuse, opposite, and adjacent. And we'll go through this in an example here in just a second. But let's just walk through the strategy. Then I'm going to ask the question, for the angle that I have been given, what side of the triangle have I been given? Have I been given the hypotenuse, the adjacent side, or the opposite side? Okay. Maybe I'll have been given the hypotenuse, maybe I will have been given the adjacent side, or maybe I will have been given the opposite side, a value for that. Then I'm going to ask the question, for that angle, what side of the triangle do I want? Do I want the hypotenuse, the adjacent, or the opposite side? Okay, so if I, for example, was given the hypotenuse and I want the adjacent side, because I know my mnemonic, if I've been given the hypotenuse and I want the adjacent side, I know adjacent and hypotenuse are associated with cosine. Okay, so then I'm going to write down cosine of theta. I'm going to write down the definition equals a over h. Then I will have some labels on the diagram for each of those sides, and I'll write down whatever label it is for the adjacent side and the hypotenuse. And then I will say, oh, I want this side. Okay, I want this side. So I'm going to isolate that. I'm going to take what's in the denominator and put that on the other side of the equation and get this side by itself. And I'll say this side by itself equals this side times the cosine of theta. And then I'll plug the values in and solve. Okay, so let's see how that works. So using this strategy, find the missing pieces of information in the following problems. The first one's been done for you. In each successive problem, I've decreased the amount of guidance. Now, I am not asking you to write down these questions. These are questions that you're going to ask yourself in your brain while you're doing this. Okay, so here's my triangle, and I've said I have given you this side of the triangle, and I want you to use this angle, and I want you to find this side. Okay, so given side V, or side V equals 23.9 meters per second, and angle theta 2 equals 71 degrees, I want you to find out what this side is. Okay, so a situation like this might be that I have an object that's flying at this angle at 23.9 meters per second, but I don't want to know what the velocity in that direction is. I want to know what the ground speed of it is. Okay, I want to know what the ground speed of it is. So if I find the length of this side, that will be the ground speed. Okay, so here's my strategy. I'm going to label it first, right? This is the right angle, so this is the hypotenuse. This is the opposite side, and this is the adjacent side, right? The opposite side is the side opposite the triangle, and the adjacent side is the side next to it. Okay, so here's the adjacent side. Okay, so related to this angle, what side have I been given? I've been given the hypotenuse, right? Related to the angle theta 2, what side do I want? I want the opposite side. Okay, I've been given the hypotenuse and I want the opposite side. That means I have to use sine, right? Because toa, sine is the one for the opposite and the hypotenuse. So I'm going to write down that statement. I'm going to write down sine of theta 2 equals opposite over hypotenuse. Okay. Then I'm going to substitute the labels that I've been given for that. Oh, the opposite side is VB. The hypotenuse is v. Okay, now that makes it really easy for me to see how to solve this problem. I want side B. Okay, and I'll usually circle the side that I want because I want to get that by itself. This is the side that I want. This means that before we plug values into the formula, we isolate VB on one side of the formula. We get it by itself. In this particular circumstance, in order to get VB by itself on one side of the equation, I need to multiply both sides of the equation by V. So I'm going to multiply by V here, and I'm going to multiply by V over here. And these V's are going to cancel out, right? And that gets VB by itself, okay? I've gotten rid of the V, and now VB is by itself. But I like to put my isolated variable by itself on the left side of the equation. So I'm just going to switch these things here. I'm going to switch VB over to the left side, and I'm going to switch V times the sine of theta 2 over to the right side. And now I've got a formula that I can easily solve, right? I can say VB equals V times the sine of theta. That should be theta 2. And so I'm just going to plug in the values. V is 23.9 meters per second. We want the sine of 71 degrees because that was the angle. And that means that that's going to be 22.6 meters per second. And let's go look and see if that makes sense. Okay, this side is almost the whole length of the hypotenuse, isn't it? Okay, this side is almost the whole length of the hypotenuse, so it should make sense that my value of 22.6 meters per second is almost the entire value of 23.9 meters per second, right? 22.6 is almost all of 23.9, and that would make sense. This ratio here of the opposite side to the hypotenuse is going to be close to 1. Okay? So that's how we're going to do that. Okay? Now, I have given you some additional problems with a little bit less guidance. Okay, and then the final one is going to be the one that you do by yourself. Okay, but I've also given you the ability to check your answers here. So let's see if we can walk through the second one here. Okay, given side dA equals 414 meters per second, that's this right here, and angle theta 1 is 32 degrees. I want to find side dB. I want to find out how long that side is. And since this is a displacement now, instead of a velocity, I just have meters, right? That's a displacement. I'm going to change my label to D instead of V. And I'm going to ask the question here, related to angle theta 1, what side of the triangle have I been given? Well, I haven't labeled them yet, so I'm not going to be able to answer that. So let's label that. That's the hypotenuse, right? That's the opposite side of the triangle from the right angle. Related to angle theta 1, this is going to be the adjacent side, and this is going to be the opposite side. Okay, so dA equals 414 meters. Okay, so I have been given the hypotenuse. Okay, what side do I want? I want the adjacent side. And again, you don't write these questions down. These are just questions you ask in your brain. Okay, what trig function contains both of these sides? Because I remember SOHCAHTOA. I remember that the cosine contains both adjacent and hypotenuse. The formula for this trig function is cosine of theta equals adjacent over hypotenuse. So let's substitute the labels in from the diagram into this formula. We're going to say cosine of theta equals A over H. And the labels here, A is going to be dB, and hypotenuse is dA. Okay, and now I'm going to isolate the thing that I want, and I always circle that thing that I want. I want side dB, right? So I'm going to isolate that, and so I'm going to move dA to this side of the equation and get dB by itself, and that means dA times the cosine of theta equals dB right? I've gotten dA out of the denominator, but I like things on the left side. I like my isolated value on the left side, so I'm just going to move them. I'm going to switch them. dA equals, or dB equals dA times the cosine of theta. And now I'm just going to plug my values in and solve. dB equals, and dA was 414 meters. And that's going to be times the cosine of, we said 32 degrees. Okay. And if I multiply that out, and I check my answer because I'm too lazy to go back to the calculator, I get a value of 351 meters. Okay, so I get a value of 351 meters for that. Oh, I was using the thing that I could write on, wasn't I? Oops. Okay, so that gives me a value of 351 meters, and that's what you need to put on your answer sheet. Okay, so all of that we just did would go on your answer sheet. Okay, triangle 3. I've given you less guidance here, so I'm just going to do this on your answer sheet so that we can not have to move back and forth. So given side VB, right, here's my side VB and angle theta 2. So I've been given this side and I want to relate it to this angle, which is 74 degrees. I want to find this side. So I've left out some of the guiding questions. You should still be able to think them in your head. So I've left out the first two guiding questions. I've just said what trig function contains both the given side and the side you want. Your brain goes, I was given the, and let's label these. Right, here's my right triangle, so this is the hypotenuse. This is the angle I want, so this is the adjacent side. This has to be the opposite side, right? It's on the opposite side of the triangle there. And so I've been given the adjacent side. I want the opposite side. I've been given the adjacent side. I want the opposite side. So since I know SOHCAHTOA, I can say opposite adjacent, that's tangent. Tangent. So I want to use the tangent. Write the formula for this function using the labels from the given triangle. So I can say tangent of theta equals opposite over adjacent. And then if I put my labels in, the opposite is VA, the adjacent is VB. Now I'm going to isolate the side that I want. I want VA, so I'm going to multiply both sides of the equation by VB, okay, and that's going to give me VA equals VB times the tangent of theta. And then I'm just going to plug my values in and solve. So VA equals VB, which is 191 kilometers per hour. And that's going to be multiplied times the tangent, and that's of 74 degrees. Let's actually use the calculator for this one. Just so I can see the... So my value was 191 kilometers per hour times, now I want the tangent of 74 degrees, say equals, except I can't type that in, I just have to hit equals, 666. Wow, that's a scary number. But that's the number that we got. So equals 666 kilometers per hour. And then I can go back to the triangle and see if that makes sense. Okay. Does it make sense that this side is going to be this long if my adjacent side is this long, right? Okay. So looking at it, it does look like this side might be that many times as long as this side. Okay, so it looks correct on my answer. So I'm going to let you try triangle 4 on your own. Just follow the strategy. Show me the formula you're using to solve the problem, how you isolate the desired variable, how you plug the correct values into the formula in the answer like we've done, and we'll be okay. Okay, so let's do that. I'll let you do that on your own, and then remember that you have the ability to go check your answer in the class notes. So right here is that triangle. Click here and that will give you the answer. Then I'll show you the solution. Let me just show you that that does in fact take you to the solution. Okay, so you have that, and then we just have one last exercise to work through and then we'll be done. Okay, so let me pause this here just a second. Okay, so now we're gonna do this last exercise here, and we're going to reverse this process. So this is the class notes for this last process here. And I said let's reverse this process. Previous problems have shown us that if we know the lengths of the side of a right triangle, we can find the ratio of the length of the opposite side compared to the hypotenuse, and that's the sine. We can find the ratio of the length of the adjacent side compared to the hypotenuse, and that's the cosine. And we can find the ratio of the length of the opposite side compared to the adjacent side, and that's the tangent. We've also seen that if we know the length of a side of an angle, we can find the length of a side and an angle, we can find the lengths of the other two sides. Now we've also stated that for any angle of the right triangle that's not the right angle itself, whether it's 1.7 degrees or this amount or 74.3 degrees, whatever the angle is, for that angle there is only one sine, cosine, and tangent that corresponds to that angle. So if I know the value of sine, cosine, or tangent, there's only one angle that can correspond with that value, so I should be able to find that. If I have a calculator and a trig table, or a trig table, and I know a value for a sine, a cosine, or a tangent, I can calculate one of these values using the length of the side, and I can find the angle by finding the inverse of that function. Okay, and so all we're doing is reversing the process. Before we've said, I know that the sine is the opposite over the hypotenuse. Now I'm saying if I know the opposite over the hypotenuse, I can find the angle for that. Or if I know the adjacent over the hypotenuse, I can find the angle for that cosine. If I know the opposite over the adjacent ratio, I can find the angle for that tangent. Okay, so we're gonna do that now. So the basic strategy is this: if I have two sides of a right triangle, I can find the angle, and I'm going to start out just like I did last time with the last one. I'm going to label my sides, and then instead of asking what side have I been given and what's the angle, or what side do I want, I'm going to say what two sides have I been given. Okay, if I've been given the opposite in the hypotenuse, I'm going to use the inverse sine to find that. If I've been given the adjacent in the hypotenuse, I'm going to find the inverse cosine to find that angle. If I've been given the opposite in the adjacent side, I'm going to use the inverse tangent. Okay, so ask the question, what trig function contains that side? Then write down the formula for that trig function. Then move the name of that function to the other side of the equation. In front of the ratio for that function, place a superscript -1 after the name of the function. So that just gives the theta symbol is on one side and the inverse trig function is on the other, and I'll show you what I mean by that. And then substitute the labels in, and then plug the values in and solve. So let's walk through that process. So in the following problems, I want you to find the requested angle. The first one's been done for you. The remaining three I've given you no additional help on. Okay, so in relationship to angle theta 1, this is my question. Okay, I want to find that angle. I want to find this angle in relationship to angle theta 1. What two sides have you been given? So here's theta 1, here's the hypotenuse, here's the opposite side and the adjacent side. And hopefully you can see that for this angle, I've been given the hypotenuse and I've been given the opposite side. Okay, I know that the trig function for that is sine, right? SOHCAHTOA. And I can write down the definition for that, sine of theta equals opposite over hypotenuse. And then I don't want this, I want the angle. So I'm going to take the angle over here, and then I'm going to say I need to use the inverse sine. That's what the power to the -1 means. That's the inverse sine. I want to use the inverse sine on this opposite over hypotenuse. So now I need to take that and substitute the values in for, or the labels in for, opposite side is VA, right? So that's VA there. And V is the hypotenuse. So all I have to do then is plug the values in. Okay, sine the -1 is 7.78 over 23.9, and if I plug that into the calculator, that gives me the angle that I want. And let's look at that. Let's plug those values in to a calculator. So I'm going to clear that, and so I'm going to say now I need to use the second function here. So the second sine, okay, your calculator may say a sine, or it may say sine to the -1. Okay, it just depends on your calculator. But either way, I've got the values that I need here are going to be, let's see, 7.78 and 23.9. So 7.78 divided by, what's my divided symbol? Divided by 23.9. And this is going to give me the angle. It gives me an angle of 18.997, so that's going to round up to 19.0 degrees. And you can see that's what I have put in my answer for this. Okay, so I'm going to walk you through this first one here, triangle 2, and then you can do 3 and 4 by yourself and see if you can get that. But again, you have the ability to find the answers or check the answers by going to the Canvas page. Did I close that? No, I didn't close it. Never mind. So you can go to the Canvas page, and there's the strategy written out for you again. Here's that first one that we did, and then here's the one that we're going to do. And so you can see that I've given you the solution for that in the class notes. So let's do this one here, and then the other two you can do on your own. Okay, so it says find the angle related to theta 2. So I need to find that angle. Okay, so I look at my triangle, and the first thing I do is label it, right? I'm going to say this is the hypotenuse related to this angle. This is the adjacent side, and this is the opposite side. And then I'm going to ask the question in my brain. I'm not going to write this question down, right? I'm just going to ask the question in my brain, what two sides have I been given? I've been given the hypotenuse, and I've been given the adjacent side. And that means cosine, right? AH cosine. So I'm just going to write down cosine of theta equals A over H. And oh, by the way, A is D, and H is dA. Okay, and what side do I want the angle of this, right? And I don't want the cosine of theta, I want theta. I want theta, and it's actually theta 2. So I want theta 2, so I'm going to say theta 2 equals cosine to the -1 of D over dA. Okay, so all I'm doing is I'm taking that angle out and saying I want that angle. In order to find that angle, I need to use this function to the negative first. I've got to reverse it. Okay, and that's going to equal the cosine to the negative first of 200 and, I'm sorry, not 200. Okay, so D, oh yeah, it is 219 over 414. And I'm going to find out that that angle, let's use the calculator to find that. So here's my web calculator. So I'm going to use the second button, and we wanted the tangent, right? Let me make sure that that was what we were using. Oops, no, it was a cosine, wasn't it? It was the inverse cosine. My bad. Okay, so the inverse cosine. Let's back that up. So second cosine. And then my values, 219 and 414. So 219 divided by 414. I got to close my parentheses. And then I just find out that the inverse cosine of those values is 56 or 58.06. And write that down, 58.06. And so this is what I would need to see on the other two triangles that you're going to solve. Okay? And again, if I go to Canvas, I will find out that I have the ability to find those two answers. All you have to do is click on the click here, and it will show you the solutions to those problems. Okay? So that's this review. I know this was a long assignment. Try to complete this as soon as you can and submit your worksheets to me, because we need to try and catch up with the rest of the class. Okay? But this should give you a really, really, really good basic introduction to how to use trig functions for solving physics problems. Okay, and we're going to be using these a lot. So make sure you, if you don't understand this, you're stuck on this and it's giving you a lot of problems, please let me know. We can either do a Zoom meet or a Microsoft Teams meet, or you can send me an email to let me know what your questions are. Okay, so that's all for this video.